So today the topic that we are going to see is about Microsoft Fabric. Especially, we will try to deep dive into Lakehouse architecture of Microsoft Fabric. Uh, Before starting, a bit about myself. This is about me. I've been in the industry with especially dealing with data for around more than 15 years. I've been three times MCT and then three times C Sharp Corner MVP. I write a lot frequently on specializing on data, especially in Azure. Uh, I have a blog site. Do visit if you have time. Okay. So Fabric, you would have heard it. If you are in the data space, you cannot deny the amount of amplification the Fabric has received in the recent years. So Fabric is basically one of the Microsoft's product for data platform, which is defined as an all-in-all one analytic solution SaaS product, enterprise solution product that covers everything from data movement to data science, real-time analytics, data engineering, business intelligence, Power BI reports, something like that. So all those into one single platform, bringing every data engineering tool into a single platform. First of all, if we want to start, what is the need for bringing in Fabric when we have a lot of tools, especially from Azure itself, like Data Factory, Synapse, a lot of tools are there. But so if you're in the data space, you would have had an opportunity to work on Databricks as well. So similar to Databricks, we had recently had a few years before we had a Synapse tool introduced by Azure, and within a short span of time, again we got another one release from Fabric. So a lot of the questions that rises around us: why in a short period of time? Why would we need a lot of releases in the data space? And the thing is, Microsoft want to break the monopolization in the data space. They want to bring every data tools, every data features that is available under a single roof. So Microsoft have to have an uh, they want to democratize the data engineering architecture, data engineering tools that is available in the market because before Fabric, uh, even before Synapse, if I have to be exact, when you want to build a pipeline with some cloud vendors, you have to buy license for one pipeline tool, and then for data warehousing, another license you'll have to pay. For RDBMS data, another thing you'll have to pay. For dashboards, there's a separate licensing. So, if you take calculate everything, so there is no purpose doing everything. You will have to buy each and every tool individually, which is very costly. Also, it doesn't have a scope to minimize cost and yield a lot of benefits out of those tools that is we are using. So that is the one thing Microsoft had in mind. Additionally, they had one more important thing, that is the efficiency and the power. That is utilizing the power and efficiency of Spark engine. So they thought of how about integrating these two concepts into a single SaaS tool, like cost effective. At the same time, it's an complete, powerful, similar to the Spark engine that is available. Spark engine, which is Databricks is also using. So they wanted to combine both of these two technologies under a single roof. Additionally, with a lot of integrations with Power BI and all other tools, they want to bring it into one roof, which is called Microsoft Fabric. So basically, if you ask me what can I do in Fabric, you can do anything. With there is no uh, the amount of usage you can do, the amount of creativity that you can think of in terms of data space when it comes to Fabric. You can uh, pull up reports. You can at the end you can build a reports, but initially you can pull up a lot of data from various sources, from different cloud vendors, from your local machines. You can pull streaming data. You can pull data from different databases, RDBMSs, NoSQLs, everything, whatever you can say. You can build up pipelines, you can build up activities, even you can build a Power Query from Power BI. You can generate data from there. So a lot of things that you can do using Microsoft Fabric. So if you want to break down 5 or 6 points that I can sum up basically on a high level, what does Fabric does? So it is, if you have to say it can do data warehousing, can do data engineering, data integration, data science, real-time stream analytics, as well as business intelligence for Power BI reporting visualization. So the main pushing factor here is the ease of use. You don't have to study or prepare for weeks or months of time to just to get started, or we can get started in Microsoft Fabric within a short period of time with fantastic resources available from Microsoft Online. You can go through that, and then you can just, and they're also giving out to you 60 days of free trial, which you can test all your, whatever you have studied, you can test over there practically in the trial engine. So all these are available from Microsoft Fabric for you to practice yourself. So Fabric is basically a complete SaaS engine, which is which takes simplicity and integration to a whole new level. So it brings down the existing components similar to like the ADF, as a data factory, Synapse, powerful data warehousing engine Synapse, and Power BI especially. All these, because why am I indicating only these three? Is these three are the most commonly used tools in cloud space all over the world. So you cannot see a data team without using ADF or Synapse or Power BI. So wherever you go, if there is a data team, they will definitely use these three or at least one of these three. So these are the main three things you'll get out of Fabric when you buy the Fabric license. You can, and one more important thing is there is integration called OneLake, which is a storage layer where you can unify your data estate, and then with data science integration, you can manage your powerful AI models. You can govern your data in your data estate, like which has to be which data has to be given permission, data has to be promoted, acknowledged. There's a lot of data governance mechanism that is available when you're using Fabric OneLake. We'll see more into coming slides. Okay. So also we'll try to have this session interactive. So whenever you have a question or if you have a doubt, don't don't think twice. Feel free to pause and raise a question. So that would be interactive. That would be very lively for this session. So if you see in this session, in this slide, you can see that these are the main components, and underneath it there is a layer called OneLake with workspaces all around it. So on top of the layer, we saw that, right? In the previous layer, previous slide, we saw that what are the components. So these are the main components of Fabric. So each and every experience, each and every personas that we are going to look at, we are going to use for your Fabric exercises that you can that is built on top of these. So these are the specific uh, features or components, important components you should remember when you think of Fabric, all integrated into a single layer called OneLake storage. So OneLake is the native store without needing any additional configuration. So you don't have to integrate anything. You don't have to bind it with anything, SAS keys or access keys or something like that. You don't have to do anything. It is OneLake is a default layer, default storage layer, and it is a native store. You don't have to do any configuration. When you build your workspace, automatically there will be The one lake will be created as a background. And one more thing is it is hierarchical. So you can create a lot of folders, subfolders. It is very useful for managing across your organization. But you can only create one link per tenant. Per tenant in the sense, for example, if I work for XYZ company, so XYZ company is a tenant. Under that, you can create lot of workspaces and everything, but you can create only one lake storage layer. So that is why you'll have to use the hierarchical feature that is available to govern and simplify management across yourselves in your organization. So the one link gives you specifically single pane of glass file system namespace that can span across users and regions. All workspaces or folders, I mean, when you go and see into the one lake, you will see them as a folders. So every item you would see similar to be, it will be visually looking like a folder. So there is no proprietary formats. You don't have to, it can take any kind of formats. There is no silos. There is no, you don't have to be specific with, I can bring only this type of format, this type. It can take anything. So basically, one leg is built on top of AWS Gen 2. So uh, I think by this time, you would have figured out how this typically would be. You could have guessed it. It can take structured, unstructured. There are no specific restrictions for this. So this is what we were talking about, right? So when you go into your fabric, these are those tenant. These are the hierarchical concepts that comes from top to down. So, for example, if I work for an ABC corporation or XYZ corporation, the XYZ will be have a that will be organizational tenant. So it is a dedicated space for organizations to create, store, and manage all the fabric items. So there is often a single instance of fabric for an organization, as I said it before, because you cannot create a multiple org tenant because that will come under only one license for one organization. And specifically, it will be aligned to your organization's EAD, Azure EAD. So all your users and whatever the permissions that you are going to give, you can search through your manage through your EAD through this or the tenant. And then comes next is the capacity. Capacity is a dedicated set of resources that are available at a given time to be used. I mean, a tenant can have one or more capacities associated. I mean, one org tenant can have multiple capacities associated with it. Capacity, specifically in the layman terms, it defines the ability to uh, what do you say the configuration or the resource performance or productivity output in terms uh, if you want to set up a particular capacity with four SKUs or five SKUs, or typically you want to ration the SKUs to multiple capacities, you can do that using. We can see that how we can do that. Mostly that comes in the admin part, but you can assign different kind of memories and these configuration parameters to different sales. I mean, two different capacities. For example, here in the image, sales capacity, marketing capacity, finance capacity, anything. So you can do all these things through that. And then comes the last layer, last one before it's called a workspace. Workspace, you typically know, workspace is the one where you would be, you would do as a first thing when you go and create a fabric. So whenever whatever you do, you can't just go and create it as a single resource or a standalone service. You will have to create a workspace, and then under the workspace, you can create a multiple lake houses, data warehouses, semantic models, everything. So you can create multiple workspace. It would be very easy. For example, in this image, you could see enterprise workspace, direct scale space, direct sales workspace, multiple things for segregation. And then obviously the fabric items, the multiple items that we were talking about all this time, the warehouses, semantic models, and then lake houses, everything. So these are the basic concepts of fabric. Okay. And then coming into lake house. So any questions so far? Anybody have any questions?
Uh, but I think it's fine. So far, it's going good. So we kind
Okay.
of got a structure and everything. So it's going great.
Okay. 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 So typically, what is a lake house? We all know data lake. We all know warehouse, data warehouse. But what is these two things? Because this is mostly misunderstood term in terms of data space. Because uh, I see a lot of people, even including me, like few years before, I can explain data lake. I can explain a lot about data warehouse, obviously. But what is lake house? What is specifically built? What is the main need for building this, bringing in this term? Basically, data lake, as you would have known, uh, it you can query through the files. You can create a delta tables from data lake, and then that is one concept. And data warehouse, you'll create a lot of tables, warehouse tables. That is another concept. The binding of these two is called data lakehouse. To be specific in terms of the current context, to explain you in terms of Fabric's concept. So the foundation of Microsoft Fabric is Lakehouse, as you don't know by this time. So it is basically built on top of one lake, the storage layer, which is the common layer which we saw. So basically, what it does is it leverages the Spark and SQL compute engines for big data processing. So similar to what we see in Databricks, Azure Databricks, similar to that. So Lakehouse is an basically unified platform. You can combine the flexibility and scalable storage of a data lake, and at the same time, you can combine the ability to query and analyze from a data warehouse perspective. So you can query the files using SQL from those files which are residing in your one lake using the Spark engines and SQL engines, SQL compute engines. So basically, Lakehouse presents as a database and is built on top of a data lake using Delta format tables. Why I'm specifically saying this is uh, whatever files that you bring into this data lakehouse will automatically into the by default it will be into the data Delta format tables. So Lakehouse combines the SQL-based analytical capabilities of a normal RDBMS reservation database, data warehouse, and scalability of in terms of data lake. So Lakehouses store data formats that can be used into multiple various analytical tools and programming languages. You can use SQL Spark, and then benefits, if you ask me, what are those benefits? What are the benefits? So these are the two main benefits that you could bring on when you build up a lake house. Utilizes Spark and SQL engines for you can handle tremendous amount of data. So large amount of data for processing and analytics, and then your machine learning workloads, and then you can it supports ACID properties using Delta Lake formatted tables, and then for specifically it provides you a centralized location for your data engineers or data teams to analyze and access and utilize the data. So these are the main points in terms of data lakehouse. Okay, so in terms of fabric, so how is lakehouse is placed? How lakehouse is placed? So Uh, if you're saying I want to explore the Lakehouse, I want to explore the Lakehouse. So what are the main things that I should take care of? So these are the main tools and techniques you should take care of in terms of loading, ingesting, and then exploring the data for transformation and everything. You can do it in Spark notebooks, analytics, SQL analytics in terms of SQL that we would see practically, and data pipelines. And there is one more thing called data flows Gen 2. So we will look at what is the main difference between these two. Finally, we'll put out the data using visually using Power BI. So Spark, if you ask me, each Fabric Lakehouse can use Spark pools through notebooks. You can have a Spark job definitions to process data in files and tables in the Lakehouse using PySpark, most common, and then Spark SQL, and even in Scala, native language. You can even use Scala, depends upon your comfort. So notebooks, most interactive coding interface, which is used for mainly for ingesting data or querying through the data, or reading or transforming the data aggregation and everything. That can be done. Or if you want put out Spark job definition, you are coming from a typical Spark background or other tool background. I want to use only Spark job definitions. Yes, you can go ahead and do it. You have that choice. So, and then there is a layer called SQL Analytics endpoint. Uh, you would have been thinking, what is this all about? Whenever you build a lakehouse in Fabric, each lakehouse includes a SQL Analytics endpoint through which you can run transact SQL segments to query, filter, and aggregate, and then just like querying like a normal database. So what it does is basically, as soon as I create a Lakehouse database, automatically it will create another SQL analytics endpoint for me. So that will work as an intermediate mechanism. So I can use my normal SQL just like as if I'm querying my normal RDBMS databases, but at the same time it will make sure I'm able to communicate with the files from the Lakehouse tables. I'm able to pull out data or ingest or do anything from there. So that is the main thing, main advantage with analytics endpoints. And then the last thing, data pipelines. That is self-explanatory. You would have known in ADFs, Synapse, you use a lot of pipelines to copy data, to ingest data from various sources into your table. Similar to that, here you can pull out data from other cloud vendors or from on-prem or anything, or copy from data from there, and then move into the data into there, or pull out the data, copy to or anything. And then if you see data flows Gen 2, uh, if you have used Power Query, you would have been very familiar with this. So optionally, when you want to uh, pull out the data, transform and put the data out as Lakehouse table. You want to, for example, you have a huge file in your Lakehouse table, but just like a normal database view or something, you want to only pick out a specific amount of data, specific range, or take that data out and run a lot of aggregations and a lot of calculations through those data, and then put out in a different perspective of the table. You can use data flows Gen 2, and it's very handy if you know Power Query, because it allows you to create a data flow to perform subsequent transformations using Power Query. That is one of those features which would generally make sure it has a tight, it would generally tell us that it has a tight integration with Power BI as well. Okay. So how do we create and ingest data with a MS Fabric Lakehouse? So these are the main things, main and common ways to integrate or ingest data into a lakehouse. Normally, Yes, upload. It's as simple as that. You can simply upload just by right click upload. You can push all your files from your local into Lakehouse table. That is one of those possibilities. And then use, you can, if you're saying I'm going by my traditional method, I can use Spark notebooks. Yes, you can do that. Notebooks. Uh, if you want to use to ingest, I mean, Spark notebooks. If you sorry, these should be Spark job definition. Okay, these two. Okay, and then one is Spark notebook. Other one should be Spark job definition. That is one of those possibilities. The other one is finally pipelines. That is also possible. And then directly, uh, I mean, I told you before there is no silos. You can bring all the data into it. There is no specific formats you can use. Yes, there is no specific format. But directly, if you want to put some files into the one lake, and then from there just right click and create a Lakehouse tables on the go. So in those cases, directly supported file types are Parquet and CSV. These two are very tightly integrated, so you can just create these Lakehouse tables very easily. For other types of file formats, still it's possible. You'll have to use a pipeline or data flow mechanism and you'll have to create a source and sync from there. From there, you can convert your source into your destination would be a Lakehouse table. That is also one of the possibilities. So again, once if you loaded all your data into it for exploring, you can use notebooks, Spark definition, Spark job definitions, and then analytic endpoint, data flows, data pipelines. So these tools are available for you to explore, ingest as well as explore the data that are into your Lakehouse tables. So we'll look. I'll quickly try to show how to load. So question so far, if there is anything, just pass me in between, and then you can ask any question. So are you able to see my screen, right? The Fabric home screen.
Yes.
Okay. Okay. So this is where you'll, if you're new to Fabric, this is how the landing screen would be. So there won't be any options. Plainly, this would be your landing screen. From there, you'll have to select. These are called the personas. So Fabric has a lot of personas depending upon your requirement. Yeah, for example, I'm here. I'm going with data engineering. So in data engineering personas, first thing you'll have to create it a workspace. So I've created one workspace. For example, in today's state, test workspace, temp workspace. So I'm going with my workspace. So this is the workspace. Once you click it, you'll see all those that you have created. So this shows I have created a data flow pipeline and then a Lakehouse and then a notebook. So you can do all your things into your workspace for ease of managing all your exercises and everything. So for organizing all your creations, you can always create a workspace, and then from there you can, like this, you can go and create. These are the options available. For example, if I want to create a lake house, I can create. So this would be the default view of my created lake house. So if you see, you have it here, tables and files. This is called a Lakehouse Explorer. You will have a tables and files, and above it, so it says SQL Analytics endpoint SQL querying is available. So created SQL Analytics endpoint. That's what the alert says. Successfully created SQL endpoint analytics. So this is Lakehouse, and if you go and click there, it will throw you a view of normal databases that you would often see, schemas and everything. So this is the integration point here. So here I can simply go ahead and upload my files from my local if I want. So if I'm trying to, for example, if I'm trying here, I'm trying to upload 3 files. Okay, it's uploaded. You can go and see here. See, all these files have come. So if I want to create a table out of this, since I have told you the direct load file format should be CSV and Parquet. So I have the option to create a file from this, create a table, Lakehouse table directly from this file. If I want to create a table, I can simply say table or something, whatever I want, I can give the name and then I can create a table, it will automatically create a table. Or if I'm thinking I have around 100,000 files over here, I can do it one by one. In those cases, you can also create in bulk. For example, I'm creating a new subfolder here, and then from there, I can again.
Vinod, can this process be automated? Like maybe some system is automatically uploading a daily export onto this Lakehouse?
Yeah,
Like,
you
does it?
can use the pipelines.
Okay.
You can use, yeah, you can use.
Because this is one of the most common requirement, right? Where we are getting data from third-party system in CSV format, and then we just
Yes,
want it to be available. So,
yes, yes, you can do that.
thank you.
Yeah. So if I see here, again, I've created 3 files in the subfolder. I can go ahead and create them as a table. So automatically what happens is it will append. So if you have different format of tables, then that will fail. That's obvious. But if you say I have all around the same number of columns and same, it's like just what Sudhir has asked. If there is a daily incremental data that is coming and placing over this folder, I want to make sure I'll create whatever the data comes in the next morning. So you can, if you want, you can create a table, subfolder tables, and then you can straight away you can create what is the separators and everything. It will create your table over here.
So Vinod, uh, along the same line, if a file automatically gets uploaded here, will it automatically become available in my table? Like, will Lakehouse take care of it, or I have to make some processes where it reads data from the new file, provided that
No,
it has the similar structure?
yeah, automatic detection is there. I have read, but I have not tried it. Even I wanted
Okay.
to try it. I haven't
Mhm.
tried it, but in documentation it's there.
Okay. Because then it will make
Now,
very useful, right? Where
yes,
if the
correct.
data is automatically getting refreshed.
Yes. So now it's created. So if I go and so you see, all those data. These are the first 100 rows. So I I I wanted to append all those files into a single table. So these tables has come to me, and from here I can just query like normal SQL engine. See here, normal select. There is nothing new here. Normal select, I can do it. So you are doing it normal SQL select out of your Lakehouse table without any Spark parameters or Spark terms here. So it will, if you look at into your analytics endpoint perspective, this will be a normal database with views, functions, store procedures, and everything. So by this way, you can make sure you are able to build a lakehouse in on the fly without any delay. So this is the easiest method. You can do this for Parquet, and then you can use it for CSV. So now, what if I have another file or another file format? I have it with a different file format, and I want to make sure that is loaded as well. So in those cases, you'll have to, yeah, good.
Yeah, Vinod, I think for the everybody here, most of us may not be aware about the Parquet file format and how it looks, and how to get that one of the like CSV. Most of us, it's very common, right? But Parquet file,
Yeah.
do we get it from a specific system, or just curious? I'm just trying to, if you have
You
any
mean the
example.
Parquet is another file format which stores data in a columnar level. So if you see here, I'll show you.
Do you have some examples of Parquet files
Yeah,
here?
yeah, I'll show you.
You see, when I was going through this fabric training, right, Parquet was some new term that that I learned. So I haven't personally seen that.
Parquet is one of the finest formats for your big data workloads because it goes around by your columnar level data. Storage is columnar level, so it is very fast to retrieval and everything. So, for example, if you see here, public holidays, tax period, okay, these are the Parquet formats which
Mhm.
I'm trying to load here. So, similar to that, you can simply go to your
Like when we load it to Lakehouse table, it will all look the same, right? Just rows and columns. The only thing
yes,
is the
yes,
storage
yes,
is different. Yeah.
yeah, everything will be same. You won't feel the difference that it is a lakehouse or a normal data warehouse.
Whether it is coming from CSV or whether it's coming from
Yeah,
Parquet. Thank you very much.
yeah,
Thank you.
I'll come back to this. It is 4 MB. I think it's taking some time, but I'll come back to this. Okay.
Okay.
So the other one very common format that we would see is normally we will receive a question like when I have my files in ADL list or as you said I've created files. I've stored my files in one lake. So I want only through notebooks. This is where I want to load. I don't want to use this GUI method or click and drag. I don't want this. So that is very easy, even further easy than what we've seen before. So if you see here, uh, this is only one line of command you will have to do. Normal
Mhm.
read command that we use in Spark. The only thing is the file path that we would use is you will have to make sure you take out the ABFS path. So you shouldn't take the blog path or DFS path or something. So here, for example, I have a lot of files in pin sample underscore files. I make sure I'll take out the ABFS path here. So how do I take out the ABFS path? I'll go here, Go here, go to copy ABFS part.
EBS. Hmm.
Yeah, when you create copy here, it will automatically come over here. And from there, for example, if I'm trying to load here.
And then ABS FS is folder level path we have to take, right? Not
Yes,
the file level.
yes,
Okay.
not file level, folder level. And then we'll also have a common question like I have my files in a different workspace. For example, we are in the same team but have a different workspace, different segregations. So I don't want to copy paste things and send over the files. So is there a way I could pick out the files from his workspace to my workspace just by simply giving out the path? Yeah, that is possible. You can
Okay.
read out the
Awesome.
files from different workspaces only. So here it is done. It has loaded all the files. And if you see here, 2080 rows. It has loaded all the files here. So similar to this, if I'm having, for example, this is the workspace. The current workspace you are looking out is test workspace April 122.024. This
Hmm.
is a different workspace, Lakehouse underscore WS. I want to pick out the files from different workspace here. Again, it is possible. So here you go. Again, the count would be the same, 2080. It is again possible. So
And
okay, yeah, yeah,
Vinod,
go ahead.
is it like this is like across workspace, but we had another thing called what was the below tenant capacity. So does it
Capacity.
goes across capacity as well, or it is limited to the capacity boundaries?
No, I don't think you can go across capacity because
Okay, then.
capacity it's completely different. For example, if you see here, uh,
Well, basically, Fabric, brought a lot of new terms, right, in terms of
yes,
architecture
yes,
as well. And then I think it will get once we start using it, it will get common across.
definitely, definitely. So these are your settings. For example, capacity is here. So if I want to see what is the memory capacity I'm using, this is the
Hmm.
one. I'm using auto scaling 1 to 10 number of nodes, memory optimized, medium layer. So this is called starter pool. This will be managed by your admin team normally.
Hmm.
So if you
Okay,
want to create a new pool, you can create, but your admin team, if you given permission, you can automatically do.
I
Just like
see.
normal Spark configuration.
Hmm.
So what environment, concurrency settings, what is the Spark environment version you want to take,
Okay,
everything,
okay.
logging mechanism, everything you can from here can take.
So I think capacity is the like power of processing engine, I would say,
Yes,
right? And then workspace is
yes,
the actual boundary, the security boundary. And then
yes,
10. I
exactly.
see. Okay, okay.
Yes.
I thought it was another boundary. So,
No, no.
like how many processors you want to allocate and for your
Correct,
workspace.
correct,
Okay.
correct. Okay. So you say, okay, I've read my files. I want to write it into a table. So again, it's a simple write command. You'll by default it will be a delta format. So I'm mentioning delta format. I'm writing a table as fin sample table. So the DF is this one, first data frame. I've read the files into the data frame, and from there I'm trying to create as a delta table. So from here, if I give it, so these are the files that we created the tables with. So this is how it will look. This is the other data frame. Sorry, I think one I used for testing. So this is how you could use it as a use for creating reading out your files into a data frame. From there, again creating into data lakehouse tables. This goes for lakehouse, different workspace as well. You can easily create them. So these are the most common methods. This is very simple table read. If you're in the data space, you would have probably known this very simple thing, but I would urge you to practice more bigger workloads, bigger things. Just I wanted to give a high level overview on what are the capacities that you can do with Spark. So if you have any questions, yeah, please you can ask.